The topic is volumes of solids of revolution, the washer method. So let's do this example. The region bounded by the curve y equal x squared plus 1 and the line y equal negative x plus 3 is revolved about the x-axis to generate a solid. Find the volume of the solid. So the first thing, we need to draw this region. So to be able to draw this region that's between two curves, we need to find the intersection, the point of intersection. So to find the point of intersection, we need to set the two y's equal to each other. If we do that, we'd get x squared plus 1 is equal negative x plus 3. And to solve for x, what we do is subtract minus x plus 3. In other words, x squared plus 1 plus x minus 3 will be equal to 0, which means x squared plus x minus 2 is 0. To solve this quadratic equation, the easiest way is just factor it. So this is going to be x plus 2, x minus 1 is 0. So we got x equal negative 2 or x equal 1. Now when x is equal negative 2, we need to find the y value. Y value, you can plug it in either, plug it here or here, it doesn't matter. So if you plug it into x squared plus 1, you'll get 5. Negative 2 squared plus 1 is 5. So my first point of intersection is negative 2, 5. That's 1. And then the second one is x equal 1. X equal 1, again plug it in. It doesn't matter where you plug it, just plug it here again. 1 squared plus 1. So y is equal 2. So my second point is 1, 2. That's the second point of intersection. So let's do that. So 1, 2 would be right here. And then a negative 2, 5. This is negative 2, 5. Now we can graph. So to graph y equal x squared plus 1, we know that's graphing y equal x squared, the parabola, and shifted 1 unit up. So the vertex is going to be here, but I'm not going to graph all the way. So I'm going to stop here. And then I'm gonna stop here, right? But you can tell that's y equal x squared plus 1. Now I need a line y equal negative x plus 3. I have already the 2 points, so all I need to do is draw the segment line, right? Okay. Now now we need to, the region, this is the region right between, I don't want to draw on it, this is the region, and it's gonna be revolved about the x-axis. So in other words, all we care about, if we take an x here, some x, if we can take this line segment from here to here, and if we revolve it about x-axis, we are gonna get a washer. Why washer? Because it's gonna be, because this line segment doesn't go all the way to the x-axis. So the washer is gonna look like so the washer has two radiuses. This radius, which is the inner radius, so R inner, and of course this one, and of course it's called the outer radius. So once we find the R inner and R outer, the rest is pretty easy. So The R inner is going to go from the x-axis to this point. Let me do it this way. If you do this, the R inner, this is the R inner from here to here, and it's equal to R inner, and it's actually equal to x squared plus 1, right? Because we go in from the x-axis to the curve y equal x squared plus 1. So in other words, the y coordinate of x is just x squared plus 1. Now the outer is going from the x-axis to this line. So I'm doing a horizontal line just to show you. So the R outer is going to go from here to here, right? In other words, from the x-axis to the line y equal negative x plus 3. So the R outer is equal negative x plus 3, right, at x. So let's write them down here. So R inner or R outer is equal negative x plus 3, then R inner is equal x squared plus 1. Now the volume by definition is going to be the integral from x equal a to x equal b, and here we have x equal negative 2 to x equal 1 of a of x dx. A of x in this case is the area right between these two. I'm drawing it right here. So this is the ax. So how do we find a of x? It's pi times the outer radius squared. So in other words, here we can just say volume is equal negative 2 to 1. It's pi times the R outer square minus pi the R inner squared, and everything dx. In other words, it's the area of the big disk minus the area of the small disk. So the volume is equal the integral from negative 2 to 1 of pi. The R outer we said it's negative x plus 3, so square it, minus the R inner we said it's x squared plus 1, but we need to square it, and don't forget the pi, and then all of this dx. Now the volume is equal, I mean, we can FOIL all that stuff. You know how to FOIL it. If you FOIL it, you're supposed to get integral from negative 2 to 1 pi 8 minus 6x minus x squared minus x4 dx, which is we can take the pi outside and then integrate. That would be 8x minus 3x squared minus x cubed over 3 minus x5 over 5 between negative 2 and 1, and that's just algebra. If you plug everything in, you're supposed to get 117 over 5 times pi, and that's our solution. Let's draw the volume. Let's draw the solid. So if we want to draw the solid just to see how it's going to look like, we're going to do reflections of some point. So reflection of this point it would be right here. The reflection of this point would be, let me see, 1, 2. It will be right here. The reflection of the other point, let me see, 1, 2, 3, 4, 5. 5, -2 would be right here. So it will be something like this. And this is going to be a line. In other words, we did the reflection of the whole region with respect to x-axis, and then revolve it means, so it's going to look like a ball cut off at x equal 1. And then of course, if you want to make the sticker right, and that's it for this example.